Hello, I'm Dan Cook with BoneZone, and welcome to our webinar on advancements in metallic materials for orthopedic implants, presented by Carpenter Technology. Carpenter Technology specializes in a versatile alloy portfolio featuring titanium, cobalt, nickel-based, and iron-based materials. Their focus is on providing top-quality materials for medical devices and contributing to improved patient outcomes. Carpenter Technology also offers additive manufacturing solutions to complement its raw alloy expertise. Presenting today are Ray DeFrain, Carpenter Technology's Manager of Regional Metallurgy, and Dr. Gaurav Lalwani, Global Strategic Business and Applications Development Lead at Carpenter Technology. Before we get started, a quick note to let you know that we will take questions after the presentation. You can use the Q&A box at the bottom of your screen to submit your inquiries at any time during the talk. With that, I'd like to hand it over to Gaurav.
Thank you, Dan. A very warm welcome to all the attendees. My name is Gaurav. I will kick off the webinar by providing a brief background about Carpenter and then hand over to Ray for the technical presentation. So Carpenter Technology is a 134-year-old specialty alloys producer. It started as a steel company, and we've transitioned to a specialty alloys producer over the years. Today, we provide mission-critical materials for several end-use applications across a variety of market segments. And we have melt technologies that provide a wide range of products and solutions for different applications that you would see in the next slides. Our vision is to be the preferred solutions provider in the specialty metals industry. Safety is our #1 priority. We do not compromise on quality. We value our customers, and we focus on innovative new products to help our customers meet their needs. Carpenter is a global company. We have more than 4,000 employees scattered across the globe, with more than 200 metallurgists on staff, sales channels and manufacturing locations across several different continents, and warehouse and logistics services across the globe as well. Strategic markets that we serve are automotive, energy, aerospace, consumer, defense, medical, and industrial. And we also provide additive manufacturing and electrification solutions as our 2 growth platforms. We have about $2.7 billion in annual revenue and a portfolio of more than 500 different alloys and custom compositions that we offer to the industry. So talking about portfolio, we provide stainless steel-based materials, nickel-based tool steels, cobalt-based materials. We also provide titanium, super alloys, alloy steels, and a lot of different custom chemistries, and several different product forms, round bars, shape bars, coils, plates, ultra bar, wire, strip, and powders, to name a few. Again, these are just our core values. We focus a lot on safety, zero injury workplace, transparency, above the line accountability. We also value working collaboratively with our customers in developing new products and solutions. With this, I'll hand over to Ray for the next set of technical slides. Thank you.
Thank you, Gaurav. Good morning, everyone. Good afternoon and good evening to those joining from us abroad. I am going to shift into the technical portion of this presentation. I am going to turn off my camera as I do have some internet connectivity issues here, but it is a pleasure to meet many of you here online virtually. At Carpenter, we're working at many different materials in our stainless steel, titanium, and cobalt portfolio to focus on advancements and support the voice of the customer when it comes to needs and gaps within the medical community, specific to orthopedics, instrumentation, and implants. So this presentation will focus on the advancements in each of those categories. On the slide we see here, we'll be talking specifically about stainless steel and the areas in which we are growing, both to support regulatory challenges, to support manufacturing and supply chain challenges, and then certainly, and most importantly, to improve patient outcomes. So in the first section, supporting regulatory challenges, we first must talk about some of the chemical challenges and how Carpenter can support from a melt perspective. Gaurav, please go to the next slide. Melt technology is incredibly important. Melt technology is what defines the capability of your component to succeed and defines the performance characteristics of that material to your design criteria. It's the first place, it's the first step, and it is the definition of the success for your particular component. At Carpenter, we have many different melt technologies, but it's the consistency that we drive that allows us the opportunity to push material performance to the next level, to drive chemistries beyond that, what is standard in a cast and wrought process, to provide a microstructure and performance that meets the expectation of the customer. Ultimately, Carpenter starts with raw materials that we define, bags of elements and very highly controlled scrap streams to drive an incredibly controlled melt product that supports the applications that we're going to be talking about in the next few slides. The first section we'll talk about is our EU MDR cobalt restricted materials. Specific to the stainless steels, many of the stainless steels that we have provided and continue to provide to the medical market for instrumentation has a historical type analysis that will have cobalt contents greater than 0.1%. Many of you may be familiar with the EU MDR restrictions on their CMR labeling requirements for anything equal to or greater than 0.1% of cobalt. At Carpenter, we have many different of our standard stainless steel materials. So 17-4, custom 465, 410, 420, the list goes on, to be able to drive a hyper control within our scrap stream and raw materials to support a cobalt restricted variant and support your compliance with the EU MDR regulations. Many of those regulations are in effect today. Many of them are in process, and many of you are familiar with the timeline and schedule that will be coming in just a few days and also in a few months in September. And Carpenter is here to support from an instrumentation side on the cobalt restrictions to ease the process into a material that is compliant with the updates in the EU MDR. Additionally, we have materials in stainless steel that have further advancements in strength requirements beyond what historically has been used as the gold standard for stainless steel implantable material. Stainless steel 316 vacuum melted material, or what Carpenter calls Biodor 316 LS, has been the gold standard as a high strength implantable stainless steel material that has great biocompatibility. However, additional need in both strength, corrosion resistance, and nickel and cobalt sensitivities have driven Carpenter to develop additional alloys in this space. Biodor 734 and Biodor 108 address concerns for both EU MDR, and in the Biodor 108 support nickel sensitivity concerns as well. At the bottom of this slide, you'll see the mechanical properties have also been enhanced to answer some of the questions and concerns of next generation high strength material in this space, which can be used both for instrumentation or high strength implant materials to support minimally invasive surgeries and better patient outcomes. In addition, the stainless steel is an additional area to support the manufacturing processes. We'll talk about two areas that we can support you on a manufacturing, contract manufacturer, tiered supplier, but also the supply chain to ease some of the challenges in getting material on time and that is reliable for your process. One area of concern that has been consistently talked about throughout the industry is material deflection during the machining operations at contract manufacturers, OEMs, tiered suppliers, and those concerns driving parts that are no longer in conformance. Carpenter has taken it upon ourselves to tackle some of the inherent stress characteristics of the material that we supply that is the input feedstock for your particular process or your supply chain partner. We've developed a proprietary process to understand and control the stress that exists within the material to help you in your manufacturing process. We've worked with modeling and also process control, as well as other attributes of the material to drive a controlled process that helps control your component success. Additionally, Carpenter continues to endeavor into additional heat treating processes to support a faster go-to-market strategy for some of the materials that you work with today. Those may be some of the standard martensitic, straight martensitic stainless steels, such as the 410, 420, 440 series material, and also the precipitation hardenable materials such as 17.4, custom 450, custom 455, and custom 465. We're supporting this industry by providing a wider breadth and a continuous improvement in that portfolio of material that has a wider capability of pre-hardened supply. This can give you an opportunity to shorten your overall process flow from securing material, doing potential partial machining, sending for external heat treatment, bringing back that material, doing additional machining steps before you're then able to get to a semi-finished component for EP or polishing. Now we have a process that can support you direct feedstock that's allowing a direct to machine finished component, allowing you to skip many of the parts of the current process today. And lastly, in stainless steel, there's a major focus on driving improved patient outcomes. Some of these areas I've talked about already as we focus on EU MDR as a prolific conversation throughout the medical market. Biodor 734 is a highlight alloy, not only supporting the EU MDR compliance that we're all beholden to, but it also drives an improvement in strength beyond that of the 316 LS variant. In the image below, at the bottom, there's a table that shows a few different characteristics of the material in different conditions. This allows you to provide a material that is beyond that, even in the annealed condition of the 316 stainless, but with additional cold work provides additional benefit in strength while maintaining a high level of ductility. In addition to Biodor 734, Biodor 108 is an alloy that we're continuing to support and push throughout the market as it gains wider and wider adoption throughout the medical community. Biodor 108 is also a nitrogen-strengthened austenitic material with high stability in the austenite structure and allows us for significant improvement in both corrosion resistance and a material that is higher strength, supporting some of the voice of the customer and needs for a higher strength material beyond that of the 316 stainless. This implantable material provides a nickel-free and cobalt-free material compliant with the EU MDR and also supporting the nickel sensitivities of many of the customers within the market. We have an additional webinar on this particular alloy. I would encourage you all to have an opportunity to look at that, and it is referenced in this presentation. Many of you may be familiar with Custom 465, Carpenter's gold standard when it comes to high strength precipitation hardenable material. Custom 465 is used in various conditions, in different heat treatments, and in different supply modes throughout the medical community. One area that we want to make sure people are aware of is that Custom 465 oftentimes obtains some of its greatest strength and performance through additional cold work conditions. There has been a myriad of different requests from specifications and customer requirements that identify cold work in some cases and do not include cold work in some cases. And it's important to note the latest revision of ASTM A564 includes the cold work condition to make it easier for supply chain, OEMs, design engineers, and contract manufacturers to reference the requirements within and provide a better and more consistent request and clarity between expectations and specifications. Similar to my previous conversation on Custom 465, it's important to note that Custom 470 is also a material that's available from Carpenter. Custom 470 is a modification of Custom 465 that improves the machinability and drillability of this common material. Custom 465 has been used in many, many applications, whereas Custom 470 is effectively a drop-in solution that enhances the machinability of this particular material. This material is born of a powder process, so it is slightly different than the cast and wrought process of Custom 465. But it is important to note, in special applications, such as needles, for example, it's an alloy that provides significant improvement on the drillability and machinability of that particular component. And then lastly, and I would say I'm very excited about this particular material, is Carpenter A421. Carpenter A421 is a new to world material. What that means is nobody else makes it. Nobody else has played with it yet. This is brand new, a Carpenter innovation born internally. And we're working today to identify partners in this next generation advanced martensitic material. This material is incredibly unique. It's a martensitic material that both has incredible corrosion resistance, incredible hardness, and incredible toughness at the same time. This material is also a low cobalt material. You may be surprised to hear me talk about a high corrosion resistant material that has greater than 62 HRC hardness capability. You may also want to compare this material to some of the other standard martensitic materials that exist for some of your straight components within the instrumentation space. This has great torsional capability, high toughness, high yield strength, and has a great performance in many of its wear components and attributes, with a very aggressive salt spray corrosion resistant test. This material stands proud against some of its other high hardness counterparts. Now we're going to shift into another section, talking specifically about some of the advancements in our cobalt-containing materials and cobalt-based materials. Specifically, we're going to talk about cobalt chrome molybdenum, or what Carpenter calls Biodor CCM. Carpenter cobalt chrome molybdenum, or CCM, is all governed by the ASTM F1537 specification. In other words, we're producing a cast wrought product, and we are producing that in bar and or wire. Other materials in this space are produced to F75 for castings and F799 for forgings. And Carpenter also produces material through a powder process. Many of you may be aware of CCM, but some of the driving factors for maybe some of the newer design engineers that may be on the call is that this is a cobalt-based material that provides very high levels of strength and wear resistance, galling resistance, and fantastic corrosion resistance. It's non-magnetic in all of its conditions, and it has 30+ years of use in many of the medical surgeries that we work with today. So you may be asking, where is the advancements in CCM? Maybe you're very familiar with CCM and have been using it for some time. I've seen the participant list on the call today, And many of you are familiar with CCM and use it on a daily basis. So you may be asking, why is Carpenter talking about cobalt, chrome, molybdenum, and the developments in this particular alloy system? Well, I would say we have 8 different variants of CCM. That's quite a bit more than the 3 variants that are listed in ASTM F1537. And those were born out of an evolutionary innovation process at Carpenter through many years of working with customers to support a few different characteristics that were necessary on voice of customer needs. Specifically, we had areas where we needed improved processability, areas where we needed improvement for printability, areas where we were focused on a lower level of nickel to support nickel allergies and nickel sensitivities. And over the years, we have generated 8 different variants of the CCM platform, 3 of which that exist within the alloy 1 space, one that has a improvement shifting from Biodor CCM to micromelt for a consistent microstructure, smaller grain size, improved processability. Another variant changing the nickel content to support some of the nickel sensitivities within this market. We have another alloy that's what we would consider an in-betweener. It's called CCM MC, and it supports materials from a powder perspective and drives additional osteointegration and better diffusion bonding. This formally sits within the alloy 2 of ASTM F1537, but is a powder product. In the alloy 2 space, we have our Biodor CCM Plus, which is the higher carbon variant of CCM. And we have the variants similar to what we saw in the F1537 alloy 1 space. We have an area of low nickel to support the nickel sensitivities, and also a modification to have improved processability. This alloy is currently not available. Actually, it's going back for additional redesign within our R&D development team. And then lastly, we have our gas atomized dispersion strengthened alloy 3 variant of the CCM family. This drives higher levels of strength and fatigue through the addition of rare earth materials, providing a high strength even when fully annealed. Lastly, we're going to talk a bit about titanium and some of the advancements Carpenter has been working on and supporting both from a cross-pollination standpoint and some very novel processes in the titanium space. Many of you on the call today are familiar with the CP, Ti 6.4, 6.4 Eli, 6.7 materials that are used throughout the industry and continue to proliferate into additional applications on a daily, weekly, and monthly basis. Titanium is a wonderful alloy providing great levels of biocompatibility and has been found use in many applications, implant applications, and also surgical tools. Many of those examples are provided here on this slide deck as titanium continues to be used more and more each day in the medical space. We're going to focus for a moment on Ti 6.4 and 6.4 Eli, or extra low interstitial material. Again, many of you may be very familiar with this particular product and its use throughout the medical industry. However, Carpenter doesn't only play in the medical industry. I have an interesting note on the side of this slide. Oftentimes, titanium 6.4 material is provided and used in the annealed condition within the medical market. However, Carpenter works very closely with the aerospace market, and oftentimes solution treated and aged is the ideal process for the aerospace market, providing the highest strength option, but it's not explicitly covered in the ASTM specifications that govern the 6.4 material. It's very common condition throughout the aerospace industry, and it's very interesting to think about this particular material being leveraged into medical and supporting our customers by providing a material that is in the solution treated and aged condition. I think it's important to look at some of the potential properties you can gain by shifting to the solution treated and aged. This is a drop-in solution for some cases of material where additional strength is necessary in a as-proven, non-changing material solution. Titanium 6-4 can boost its strength by nearly 20% through the solution treated and aged condition while retaining a significant portion of ductility. Lastly, we'll leave you with one teaser slide. This slide is a focus on some of the work we're doing in nitinol and some of our additive manufacturing. You'll see in this video that we've created a bone staple out of nitinol 3D printed material. That's all we have for you today. Do you happen to have any questions? Feel free to use the chat box and Q&A section of your panel.
Thank you, Ray. We do have several questions coming in. The first question is, I recall you discussing an A21 variant in a previous meeting. Were my notes incorrect, or how does this material compare to A421?
Yeah, so A21, it's glad to have somebody back in one of our webinars. Again, that was in one of our previous. A21 is a material that Carpenter provides and is also the sister alloy to A421. So very astute in catching that. A421 is a product that has a full chemistry and full heat treatability, whereas a A421 variant of that material is a carburizing material. So supporting a surface enhancement from a hardness capability. A21 is still a material that is available at Carpenter, and it is gaining quite a bit of traction throughout other markets where carburizing is a standard process. In the medical side, A21 there are some additional barriers, whereas A421 has been more widely accepted and additional interest due to its difference in thermal processing.
All right. We have another question. You mentioned a cobalt chromium molybdenum alloy that performs better in diffusion bonding. How so?
So, first of all, CCM MC, it's a medium carbon content material. That particular product has a very tight chemical control and a very tight consistent chemical control, being born as a powder product. The diffusion bonding characteristics of that particular material happen to be in a sweet spot of the carbon content between the alloy 1 and the alloy 2, and feedback to date has been it's an improvement on some of the other currently available options in the market.
Perfect. We have another question on A421, Ray. So it says A421 is a stainless material, but how does it compare to 440A or custom 465 for corrosion resistance?
I think you may have cut out there, Gaurav, but I'm not sure what the other. Okay. Could you repeat the question?
Yes. Sorry about that. So the question goes, A421 is a stainless material, but how does it compare to 440A or custom 465 for corrosion resistance?
Sure, fair question. So A421 is a material that's in the realm of a 420 stainless. So as far as the corrosion resistance versus a 440A, this material is stabilized to provide a consistent and protected chromium content within the product. So although it is able to obtain very high levels of hardness, we don't lose some of the chromium that would be tied up in a conventional martensitic with carbide. So instead, we're able to provide a highly corrosion resistant material. However, compared to a custom 465, custom 465 also has quite a bit of nickel content. Custom 465 is a highly corrosion resistant material, but we are challenged with some of the hardness that it is capable to obtain. So this material, A421, is truly a gap material, and it's also a material that is very unique for a straight martensitic product to provide high levels of hardness, high levels of yield, and also high levels of wear along with its corrosion resistance.
Perfect. The next one is, this is the first time hearing of Custom 470 stainless. Is this something new, or has anyone else used it before?
Yeah, so Custom 470 has been around for some time. We have additional individuals looking at it routinely. It's more of an awareness item as we continue to provide different variants on our custom series in the precipitation hardenable space. Custom 470 has precedence of acceptability through various manufacturers to date. I will say, as another teaser, stay tuned. There's additional developments in this particular space. Not ready for prime time or webinars yet, but absolutely something that Carpenters are working on continuously to support the needs within the market.
Right, we have a few more questions coming in. You mentioned Carpenter's additive capabilities with respect to powder production. Can you elaborate on that? Describe what does that mean? Does Carpenter have the capability to produce medical components via 3D printing? Well, let me take this one, Ray. So
Sure.
we do have powder production capabilities, and we support powder production capabilities for end use in micromelt material development and production. And we also support powders for 3D printing applications, be it wirefare or powder bed fusion system or electron beam printing systems, right? However, as far as plans on printing components and entering the medical device space is concerned, those are not on the cards yet. We have no plans on entering the medical component space. Next question. In the 108 slide, early in the presentation, you mentioned nickel-free. What does nickel-free mean? Specifically, what is the maximum nickel content? Right.
Sure. So I'm not sure who asked this question, but you're obviously very familiar with this particular material. So again, another very astute question. So our data points to, or I should say our data sheet points to 0.1% maximum, so certainly not zero, right? And we say essentially nickel-free for this material, but what we are targeting is a 0.05% max nickel, and that would be available upon request. So, with these particular products and the raw material, even if we work towards premium raw material, there's always going to be a level of nickel that comes along. So we are able to push that down to 0.05%, driving an essentially nickel-free material, supporting those nickel sensitivities. That does align with the feedback that we've received for controlling the nickel content from some of the people that are on this phone today.
Perfect. All right, we have a few more questions. Thanks, Ray and Gaurav. Biro 108 is an interesting alloy that we would like to explore further, but the last time I inquired about it, it was no quoted. Are there current issues in production? All right, let me take this one. It's a good question, and they're definitely familiar with the alloy, being inquired about it in the past. For a period of time in 2023, there were challenges in meeting the melt schedule, and a lot of those roadblocks have now been addressed. We have no issues when it comes to availability of this material. It's no different than any of our other medically relevant alloys in our portfolio. So we are definitely able to support any and all inquiries for Biro 108 now. All right. Next one. For Ti-64 solution treated and aged, does the solution treatment affect the final material composition?
I'll take this one, Gaurav. No. So the solution treated and aged process is similar to what we're doing in a precipitation aged material, such as a 17.4 or custom 465. The aging process is not modifying the chemistry of the product. It's driving an enhancement in the material properties. So we're not driving any type of chemical composition change unless there are wildly out of control thermal issues, which we would control on the surface as well.
Perfect. Let's take a last one. I think it's just a comment. It says, I think we need more data on fatigue for the proposed cobalt-based alloys and stainless steels for orthopedic applications. So I think it's just a general statement, really well. Talk about.
Yeah, I would say we are always open to discussing, design criteria with customers and understanding what is important, whether that be an update to our data sheets, whether that be an update to the information that we provide on our website, or working directly with you on IP for a particular development on your process. So where you are able to identify design attributes, whether it be hardness, whether it be mechanical properties of another type, we're certainly willing to support that. I would encourage you to reach out to myself direct. My contact information should be available through this webinar, and we could discuss a bit further on what would be necessary for you to evaluate with a higher level of confidence.
And we also have a couple of comments about the presentation being available later on for reference after the webinar. And we will have a recording that will be available. So all the content would be available, definitely. All right, I think that gets us to the end. Do we have time for one more question, Ray?
Yeah, of course.
There's a lot of interest in 6.4 STA. I think the last one is, will Ti 6.4 STA maintain strength advantages through forging processes?
So that will be a bit tricky, and certainly similar to what you see on the precipitation hardenable material. Temperature exposure can modify the aged properties of the product, but that doesn't mean that the material would not be able to be aged again. The STA process is a product of its thermal exposure and its aging process. So I'd be happy to work with you on your particular process and get a better understanding of that particular product, the temperatures that it's exposed to, and what we may be able to support you from a knowledge transfer.
Perfect. I think that brings us to a close. I would like to thank all the attendees for taking the time out and attending the webinar and asking interesting questions. I appreciate the engagement.
Thank you both, Ray and Gaurav, for a great presentation, discussion, and sharing your perspective and expertise. I also want to thank the attendees. I hope you took away some valuable insights and some useful information. You can learn more about Carpenter Technologies and their expertise at carpentertechnology.com. With that, I hope you all have a great day.
Thank you.